Hello and welcome to Mastery for Raz. Today we'll be looking at integration, the area between a straight line and a curve. So here are some examples of the sort of thing we'll be looking at today. You can see we have the pink shaded region from these questions off mymaths.co.uk, and we need to know these techniques about how to solve those. So let me first start by giving this sort of notation. So I'm going to label the curve as fx and the straight line as gx. If we subtract those functions, we'll create a new function that I'm going to call h. And that's pretty much what we have to do to answer these questions. Yeah? So if we have two functions, f and g, then the integral between the curve and the line can be found by subtracting g from f and evaluating between the limits that we find when we solve those equations simultaneously. A lot to take in, so let's do a worked example to hopefully make it a little bit clearer. So here I've given those two functions, and let me get my little pen up. So if we've got two functions, y equals 4 and y equals 6 plus x minus x squared, then we will need to first set those equations equal to one another. So we have 4 equals 6 plus x minus x squared. So if I move everything from the right to the left, we'll end up with x squared minus x minus 2 equals 0. Solving that factorizes nicely. We get x is 2 and x is minus 1. So these are our limits. Yeah, so our limits will be from 2 to minus 1. This function here this function here is hx. So that's what I was calling h in the previous slide. Yeah, so we need to integrate x squared minus x minus 2 with respect to x between the limits of 2 and minus 1. Yeah, so this function here will look like something like this. So we're saying that this area will be the same as this pink area there. So by solving that, we would have solved the question. So I've got a bit more space on the next page. So let's do that. Let's go back to yellow. So if we integrate this, we have x cubed over 3 minus x squared over 2 minus 2x between the limits of 2 and minus 1. So we can sub in the 2, so we have 2 cubed over 3 minus 2 squared over 2 minus 2 times 2 minus 1 cubed over 3 minus 1 squared over 2 minus 2 times minus 1. Let's neaten that up a bit. Well, so this will be 8 over 3. This will be 4 over 2. This will be 4. This will be minus 1 over 3. That will be a half. And that will be minus 2. Which means I have 8/3, which is what? 2 2/3, minus 2 minus 4. Yeah? So let's do that. Just trying to think what's the quickest way to, well, definitely what I'm not doing is not particularly quick. So that minus 6 minus 1/3 minus 1/2 plus 2, because we've got a minus minus 2. Yep, so this would be minus 3 1/3 minus, and that is 5/6. So 2 minus 5/6 is 1 1/6. So I'm going to change that into 6. So that's 2/6. So we have 4 3/6. Now, if some of you might have forgotten or not realised, why is this answer negative? Well, that simply tells us the negative means that the area is below the x-axis. Yeah? So when we drew this, like I said earlier, it'll be quadratic, so we know that that area is here. So we ignore the sign, essentially, because we know, well, that's the answer we want. Yeah, so we end up with 4.5 units squared. Just hoping I haven't done anything silly there. Yeah, that'll be right. Yeah. So the next one for us to look at is here. It's example 2. So you can pause it now if you want to have a go first. I welcome you to do that. If not, let's just crack on. So first we set these equations equal to one another. So you have x plus 1 equals 2 plus x minus x squared. Solve it. So that follows that x is 1 and minus 1. That's our limits. Yes, these are our limits. And this is our hx. So we need to integrate x squared minus 1 with respect to x between 1 and minus 1, which will go to x cubed over 3 minus x between the limits of 1 and minus 1. So that will equal 1/3 minus 1 minus 1/3 minus 1, which is minus 2/3 and minus, this will be 2/3. So the answer will be negative 4/3. So we know the area will simply be 1 1/3 units squared. Yeah, and that's all we do. So we're saying that that area there is equivalent to the area between those limits of that new function hx that we've created. and that's it, and then we just follow it through. So last one. Is, oh, I left myself one more space there. Last one is here. So this is a bit of a monster of a question. So pause it now and give it a go. Welcome back. So first steps are the same, yeah? So we've got this x minus 2x minus 4 equals 3x minus 12. You probably noticed that that is a cubic. So we have to solve a cubic. So this is our hx this time. That's hx. But what are limits? So you need to do a bit of division or fact theorem or remainder theorem, or we can do some of this. Let's move that, track this one more. Let's put that over there. So if you using this is the calculator that you recommended, if I go to equation functions, that's A, then we want to solve a third degree polynomial. So if I type in, so that's 1x cubed minus 6x squared plus 5x and 12. That tells me x is minus 1. Or we have x is 4 and 3. Yes, so I've got or x is 4 and 3 or 3 and 4. Now, if we look at the graph, we can see that we don't need x is minus 1, yeah? So, I think I did this all flashy over anyway. So we did all of that, and we could discard that solution, yeah? So we will need to integrate this function hx there between the limits of 4 and 3, and then we'll get our answer. Yeah. There you go. So sometimes you forget that we actually haven't integrated yet because we've done quite a few steps. So now we integrate. So we've got x to the 4 over 4 minus 6x cubed over 3. Yeah, because 6 divided by 3 is 2. Plus 5x squared over 2 plus 12x between the limits of 4 and 3. So that gives us 4 to the power 4 divided by 4 minus 2 4 cubed plus 5 times 4 squared over 2 plus 12 times 4 minus 3 to the power 4 over 4 minus 2 3 cubed plus 5 times 3 squared over 2 plus 12 times 3. And this will, you could just get your calculator out at this point. So that is 64. 64 times 2, 128. That's 16. 16 divided by 2 is 8. 8 times 5 is 40. That's 48. Let's find out for 0. 81 over 4. 27 times 2 is 54. 9 times 5 is 45. And 36. I'm not sure if this is, apologies, it's got the calculator out, but. So, what have we got here? We've got minus 64 minus 128 is minus 64, plus 40 is minus 24, plus 48 is 24. And we have, well, it's all over 4, makes it a bit easier. 81, 5400, so minus 216, plus 90, and 36 in quarters would be 144. You probably would have preferred using the calculator here. No worries if you did that. So that would be 234 plus 81 will be something. 234 minus 16. Yeah, it's the same as 34 take away 16, which is 18. And 18 plus 81 is 18, what did I say? 18 to 99. So your final answer will be 96. There you go. So I hope that has made sense. The main thing is what I said at the beginning, which is if you have a function and a line, you have a function, a curve fx and a straight line gx, then you subtract them, solve simultaneously to figure out what the limits are, and then you evaluate that integral. I've been Mr. Raz. I hope you enjoyed the video. See you soon.